Hey there, folks. Welcome to the greatest day of your life. This will be the last video of notes that you'll have to take for the school year. Everything from here on out is preparing for a test and a final. So let's check this stuff out. This is 12.7. 12.7 is about the probability of compound events. So some keywords that you might not know or you might need to know for this specific lesson are all coming up right here. So here I got it. I have a compound event. A compound event consists of two or more simple events. Simple events are things like rolling a dice, drawing a card from a deck of cards, flipping a coin. Those are all simple events. Now, independent events are when we have events that completely are not going to change based off of the next thing happening. So one event does not affect the outcome of another event, and that's what it says right here. So the way that we're going to find the probability of a compound event is by finding the probability of A and B together by multiplying those two probabilities. So you more or less find the probability of one thing, multiply it by the probability of the second, third, fourth, fifth thing, and you type that junk into a calculator, get yourself the probability of all of those things happening at once then. So here's going to be our first example. Ray is flying from Birmingham to Chicago on a flight with a 90% on-time record. And on that same day, the chances of rain in Denver are predicted to be 50%. So what's the probability that Ray's flight will be on time and that it will rain in Denver? So the probability of on time and rain. So I'm going to use R for rain. So that's going to be the probability of us doing 90%. So if we did 90 over 100, and then we're going to multiply by 50%, which would be 50 over 100. And we're going to end up with a simplified answer of 45 out of 100. Even easier yet would have been to do 0.9 times 0.5, which is 0.45, so it's a 45% chance that you'll get both rain and an on-time flight for this little Miss Ray. All right, so the next one is dependent events. Dependent events are when we have things that depend on each other. So the first thing happens, and that changes the probability of the second thing happening. You'll notice that I got a dot here. I got to move it. Got to move my dot. That's the times. So the probability of the first thing times the probability of the second thing, where it's followed by the first thing. So here's how this works out. At a school carnival, winners in the ring toss game are randomly given a prize from a bag that contains 4 sunglasses, 6 hairbrushes, oh sweet, and 5 keychains. 3 prizes are randomly chosen from the bag, and of course they're not replaced because they're giving out a prize, you know. So our job is to find the probability of getting sunglasses, then hairbrush, then a keychain. So I'm going to give myself some space here to work because I didn't do that last time. Check this out. Boom. Space just happened. I know. Be impressed. Be very impressed. So sunglasses. There is 4 out of the grand total of 15 sunglasses that I could have had. So the probability of me getting sunglasses is 4 out of 15. So I gave that away. So now there's going to be only 14 things left. And there's 6 hairbrushes. So now since I gave away a hairbrush, the keychain thing has, there's only going to be 13 choices and 5 of them are keychains. So I'm going to multiply all of those fractions together. So again, I'm going to use my trusty calculator. I'm going to go 4 times 6 times 5. Turn it on first, Berman. 4 times 6 times 5 gets me to be a 120 on the top. And then 15 times 14 times 13. That's a bigger number of 2,730. I'm going to type both of those numbers into my calculator again to simplify that fraction, 2,730. And I get the official probability of being 4 out of 91 chance that I'm going to get these things happening in that order. So I'm going to ask you guys to do part B on your own. We'll check that one tomorrow when you get back. And then let's look at the next thing. Our next thing is something you probably haven't heard of before. It's called mutually exclusive events. It means that they have events that just plain out cannot happen at the same time. So if two events A and B are mutually exclusive, then the probability that either A or a B occurs at the same time of their probability. So what we're going to do is A or B, we're just going to add together those two probabilities to find out them happening. So here's how it works. In a deck of cards, getting a 7 or getting an 8. I'm going to give myself again space to work since I didn't do that before. All right. So the probability of you getting a 7 from a deck of cards. Now everybody probably knows that there's 52 cards in a deck of cards. But did you know that there's 4 7s? And did you also know that there's 4 8s out of that 52? So what we do is we just add together these two things and we get 8 out of 52, because when you add fractions, that's an ugly looking 5. I don't want to make anyone angry with me because of my bad handwriting. All right, so 8 out of 52 can be simplified. 8 out of 52, that simplifies to be 2 out of 13. So there's a 2 in 13 chance that I'm going to get a 7 or an 8. Now down here, to get not a club, not a heart, there are 13 out of the 52 that are not club, 13 out of 52 that are hearts. Add those together and you get 26 out of 52, which is 1/2 chance of you getting neither a club nor a heart. And that's how this stuff works out here, folks. I'm going to keep it under 7 minutes, so I'm going to sign off. This is the Berman Nation. You have a wonderful time. Peace out. Good luck rest of your year. Woo!